All right, welcome to another discussion with Hex Technology. This time we're going to look at washers. Washers, are they friend or foe? So for those of you who love washers, I might not listen to this if I were you, because we kind of found out that they weren't as, oh, beneficial as what we've once been told. So when we started this, we started asking questions, and the questions were, what is the most common washer purchased, right? What are Appendix M washers, and do people actually purchase Appendix M washers? Appendix M being PCC, ASME PCC1 washers. When do people use washers? What's a good K factor for the use of washers, right? Because if you're technically putting in a variable, does that affect the K factor itself? We use 550 Extreme because our friends at JetLube allow us to use their lab whenever we want to do some really cool stuff. So we wanted to see, hey, does it? And we've got a lot of data on that. So let's try it with 550 Extreme. Another one we did is, does the K factor change with different types of failure mechanisms? And we started looking at like rust, tarnish, right, painted flanges, like in quotes, failure mechanisms. Where would you put washers? Why? And does it help? And so then we'll talk about the conclusion of washers. But I first went and looked at Appendix M washers versus F436 washers. Now, F46, F40, 436, oof, has been used for piping flanges for a very long time, but they are structural steel washers. That's what they were meant for. They weren't meant for pressure vessels at first. So we've just adapted them into what we do. Appendix M and ASME PCC1, when we worked on Appendix M, we were looking at how do you optimize the footprint of the washer. Because if you've ever noticed, an F436 washer has got a really large footprint and might not fit into all applications like valves and heat exchangers, where you got like a butt weld on one side that's really close to the nut. That F436 washer wasn't meant for that. So really, if you look at like the best part of Appendix M is it looks at the size of the washer and what it should be. And it's got a lot better specifications than F436 for pressure vessels, right? So a guy by the name of Joseph Barron did a really good job on presenting this and writing this for PCC1. It was published in 2010. But guess what? We went and asked people, what washers do you use? We hardly found Appendix M washers. It was really hard. We only found one plant who uses them. And it was because they were way more expensive than the F436 washers and really hard to come by. Appendix M washers are made to, when you order them, where F436 washers are in stock. So most people don't use Appendix M washers. So that was kind of interesting, right? So those are the two differences between the two. So let's get into the study, right? We started learning a little bit about those washers. Now let's start looking at how are we going to test these? So we took multiple failure types, right? And we used A105 coupons. So our good friends at Team went and made a whole bunch of A105 coupons and we shipped them around and they tarnished these for us. They tried to emulate nut embedment more than anything, right? Like the scratches and pits that you get from nut embedment. You could do some different like scratches or tarnishing on here, but really this is the most common thing that we see in the field. We're trying to keep with most common. We always say work the correct side of the decimal. Don't work the wrong side of the decimal. So we're looking for where can we get some big wins on this, pardon me, and see what's most common. So we saw that that was most common for tarnished. Then our good friends at JetLube put in the rusted ones and did 2 weeks worth of salt spray chamber, and it was nasty. Then you've also got our good friend Jason Wright helped us paint these. We purposely painted them really, really thick. So 75% of them were between 4.5 and 8.2 mils thick paint, where PCC1, ASME PCC1 says it can't be greater than 5. So the majority of these guys were past what is in quotes allowable by PCC1. And we did that on purpose. We wanted a lot of paint on these to see what would happen. And the last one was clean, right? Just a regular clean flange, like what you would just torque on regularly, right? So those were our different coupons that we got. And here are our results. This is really amazing when you look at it. So we did 5/8 through inch and a quarter is what we can do. So we did 5/8, 3/4, and 1 inch really is what we got from the bolt manufacturers and the coupons were hard to make. So that's what we concentrated on. So 5/8, this is amazing for a clean coupon, right? So no damage mechanism in there. If you look, we are pretty consistent across the board at about that 0.15, right? This 5/8 clean coupon, 3/4 clean coupon. We're really good at that 0.15, 0.17. That's a really good range that we typically see in. It was a little bit lower on the 3/4 than this side right here. But again, right, a K factor is an educated guess. You cannot get to the 5th decimal point with them. It just can't happen. We've tried. So we saw, though, that was pretty good, right? Good performance. No washers in blue with washer and reference. So if you see, they're all pretty much the same. The reference for us was without the coupon on the hardened steel material that is on the tester that we were using, the Skidmore tester that we were using. So this guy right here, 5/8, again, pretty solid. Like you just, I'm sorry, this is for rusted. So that's clean. And if you look at clean versus rusted on 5/8 and clean versus rusted, you see the same thing, right? No big significant difference. And so this is where we start looking is, okay, is there significance between clean and rusted? Nope. Clean and rusted? Nope. If you look here, clean and tarnished versus clean and tarnished, again, we're really hovering in that 0.15, 0.16 range, to be honest with you, as far as the average goes. And you're not seeing a big significant change when you add the washers, right? And so, or when you don't have the washers, it's all the same. We didn't see any big increase of reliability off of this. So we went through and we did all those on the 3/4 and the 5/8 through all the failure mechanisms. Didn't see a lot. What we did see was on the 1-inch ones, we kept seeing, if you look at these guys, look at this. Look at without or with the washer. You see that right there? Kept dipping down below the other two. The other two are in that 0.15, 0.16 range, right? That we were at with the clean and the tarnished and the rusted and the painted. All of them are in that 0.15. This guy got jumped up a little bit to about 0.18. Had an anomaly there, but like these are multiple anomalies that we're getting there. If you look at the orange ones, they're typically further down than no washer and our reference. And we said, what is going on? We could not figure it out. It really threw us for a loop. We saw it more on the 1-inch than we did on the other ones. And so what we did is we started looking at this happened on a 3/4, but we started looking at some of these issues that we had. And we had this little jump right here. If you look at these guys, this was our clearest one that we could find. That's why we did a 3/4 one. But this is what you saw on the 1-inch. You would see this, you would be torquing up. This is your bolt load down here versus your K factor. And you're getting higher and load, and then you get this step right there, right? And it jumps down. So what we found is when you get lubrication underneath that washer, it slips. And when it slips, it changes your K factor. It actually significantly drops your K factor because we're typically used in this 0.16 to 0.18 range, right? And then you just dump down to 0.14. And so that was a big kind of made us look up. And so we said, do washers really help you out? So let's look at this data real quick. K-factor surface conditions without washers, and then this is with washers. You look here without washers, 0.15, 0.16. Painted was 0.18 on the average. So that was a little bit higher, right? But we're traditionally looking at that 0.16, 0.18 range. Here you look at with washers 0.15, 134. Okay, so this was in the 0.13, 0.15 range. Not a big deal. We think that the reason why this was a little bit lower than these guys on average, or all of these, right? Because we're basically between 0.13 and 0.18. We think a lot of the lower end of this is because we didn't have bending moments on the flange, and the flange wasn't a factor, right? We're just looking at just the surface. But yeah, I mean, okay. not bad torque values, right? With washers and without washers. Without washers, we typically look for a 0.17 for jet lube. That's spot on. A little higher over here, but not too much. 0.02 is about 12%. Why not? And then we looked at this right here, which was our scatter, right? Our scatter was actually higher with washers, 15%, 15%, right? We didn't get as much scatter. And we think it's because of the step that happens once lubricant gets under the washers. Now, people are going to say, well, then why don't you lubricate underneath all the washers? We haven't found that to be an accepted practice. I've never really heard of that as an accepted practice in any formal documentation. I've heard assemblers say do it, but then I hear assemblers say don't do it. The other thing is, how do you inspect underneath the washer for lubrication to make sure? That's impossible. By the time you put the nut on it, the only way you could do that is if somebody was painting it and then put it on in front of you, right? It's the only way you can inspect it. You can't really inspect it otherwise, I don't think. Haven't figured that one out yet. So I don't really like this whole, let's put lubrication on the washers, because then also what you've got is you've got to drop K factor. Now, if you're within about a 0.02, 0.03 in your K factor, you're pretty good to go. But once you start getting to that 0.04, 0.05, that's a significant change. That's where you're eating up that 30% that we've got for plus or minus for our accuracy, right? Would rather keep you with a K factor eating up about 10 to 15% and allow that other bits like the calibration of the clicker wrench and the calibration of the dude using the clicker wrench and so on and so forth. Let that eat up that other 30%, not necessarily just your K factor. So I found that I wasn't a big fan of washers, which goes completely against everything I've been taught and I ever thought. I mean, this is what? Because your K factor stays more consistent without it. And quite honestly, your bolt scatter is not as bad. So here are our conclusions. What are the most common washers purchased? F436 by far. What are Appendix M washers? Dimensionally more correct for flanges, have better temperature ratings, fantastic specification to use. When do people use washers? Some people use them on damage. I think if you use them on damaged flanges or to prevent damage, I think that's legit. To increase or to get a better K factor, I don't think so. So we see people do it on damaged flanges, but we've also seen some end users go 100% washers on all bolts. That's not necessarily. I don't see that as a great path forward. What's a good K factor? You know what? There seems to be little benefit in adjusting the K factor to 0.16, 0.18. You're pretty much in that range on the tarnish stuff. So if you use washers, you could use those, but you're going to have slipping that comes in. So it might be a little bit lower, but I wouldn't be on the occasional flange that you use washers. I'm not upset with using the 0.16 to 0.18. A lot of people use 0.17, right? So that's not too bad. Does the K factor change with different types of failure mechanisms? We only saw the K factor drop on painted flanges, really, right? It went from a 0.16 to 0.18, but technically most of those exceeded the limit of PCC1 with 5 mils thickness. So on that one, we can do a little bit more studies on the paint because I think most people do get a little excessive on painting and the other one, right, and insulation. Those are the overachievers in every plant. And so might need to look into that a little bit more for sure. But for K, the ultimate conclusion is for K factor purposes, it seems that the juice is not really worth the squeeze, that washers should be used to protect equipment if needed, but otherwise they add too much complexity to the joint. And we haven't even gotten into the relaxation. Do they cause added relaxation on them? We're doing a study with a customer here in a little bit to look at washers and relaxation, but that was another thing is you're adding a variable, and in that variable, it could adjust your K factor, it could mess with your relaxation, so on and so forth. So we don't know what the unintended consequences of washers are. So from what we can tell, washers don't, for industrial bolted flange joints that are gasketed, we don't see a really good purpose for them unless you're protecting equipment. But up for debate. If you want to debate this, you want to talk about it, please email us at info@hextechnology.com. And we're looking forward to hearing from you guys. Have a safe day.